Well, hello everybody. My name is Patrick McAnulty. I'm a scientist too in the program design department here at Sekisui XenoTech. And today I wanted to talk to you a little bit about considerations and calculations when you get ready to ship test article for an upcoming study. So how much do I send? That's probably the #1 most frequently asked question that our protocol design team receives. And it seems like such a straightforward question, right? Like, do you need 500 grams? Do you need a gram? Do you need 1 mg? But the answer is not as straightforward as it seems. There's a number of factors that will impact the answer to that question. For example, what are the properties of the test article? What's the scope of the work? What concentrations do the guidance documents say need to be tested for a given study type? What solvent percentage can we use in our incubation solutions? And finally, what concentration of stock solution needs to be made? We have typical amounts that we would request for a given study type. For example, for enzyme inhibition, induction, or drug transport, we typically request 150 mg a compound. And that's generally a safe bet, but it's not a catch-all. And like we just discussed, there are other things that can influence that and maybe increase the amount or decrease it significantly. These standard requests are based on 2 assumptions. #1, the compound is about 500 grams per mole, which is, in our experience, the size of a typical small molecule. And #2, we're estimating based on a top treatment concentration of 100 micromolar. Obviously, this isn't necessarily true for every type of test article and every study that we run. So commonly we'll hear things from people saying like, well, my test article is not 500 grams per mole, it's 750 grams per mole, or it's 100 grams per mole. Or what if I need to treat higher than 100 micromolar? Maybe guidance says that I need to treat at 700 micromolar. Or, hey, I don't have a whole lot of test article. What's the absolute minimum amount that you can run the study with? So we recognize that manufacturing a test article can be expensive, the material's precious, and especially true for compounds that are very early in development. So don't worry, we can calculate a more precise amount that's tailored to the specific test article in question. And we'll do that anytime that the standard request isn't applicable or a client raises a concern about the amount of compound that we're requesting. So very early on in the process, if by the time that the statement of work has been signed, if we don't have any information about the test article properties, program design at Sekisui XenoTech is going to send a table that looks very similar to the one here on this slide, and we're going to request compound information. And the properties on this table are generally going to inform the choice of the treatment range, so what concentrations we run in the study that's going to meet the regulatory guidance. So in particular on this page, we're really interested in the molecular weight of the compound, the route of administration. Is it being dosed orally? Is it being dosed through an IV? What the dose is if it's oral, the Cmax, and the plasma-free fraction are all really important factors that we need to be aware of if that information is known. Why are those properties in particular important? Well, obviously, for molecular weight, the larger the molecule is, the more compound that you need to prepare a given concentration of solution. So larger molecule, we need more compound. Smaller molecule, we need less compound. The route of administration matters because regulatory guidance specifies different parameters that are dependent upon how the test article is administered. So for example, if it's oral administration, we're going to really be interested in maybe the concentration of the drug that's going to be present in the gut versus systemic concentration. Whereas if it's dosed intravenously, we're going to be much more worried about the systemic concentration versus the concentration that's found in the gut. If the dose is oral, obviously more compound that's ingested is going to result in a higher concentration in the gut, so we want to be cognizant of that. Cmax is a really important thing. That's the maximum drug concentration in the plasma at steady state, and that's what tells us what the anticipated systemic exposure is, and we use that to calculate things. And then the plasma-free fraction is important as well. Compounds that are more abundantly protein bound are going to have less bioavailability, where compounds that are not protein bound are going to have a higher bioavailability. So what if I don't know some of that information? A sponsor says that frequently. We don't have all of this stuff, what's the next step? And that's totally okay. If we don't have human data, we can calculate concentrations based on animal data if it's available. And in the worst case scenario, if animal data is also not available, then we can just base the concentrations we use on solubility limitations. A lot of the times the FDA wants you to test up to solubility limits. So that's an acceptable solution in the lack of data used to calculate the guidance recommendations that they use. And also, Sekizui XenoTech has been running studies that support IND and NDA packages for over 25 years. So, our managers and professionals are pretty experienced in recommending treatment ranges that are going to result in quality data that's accepted by regulatory agencies. So if there's any questions about how we're going to calculate the concentrations in the absence of human or animal data, we're happy to walk you through all that. Okay, that's wonderful. So what concentrations do we need to test? So regulatory agencies have published guidelines for certain study types that recommend the highest concentration to be tested, solubility and toxicity permitting. And these guidelines have been established. They're going to be very conservative, and they're going to try to predict the worst case scenario if a drug interaction occurred. There's really four main criteria that we're interested in here. 0.1 times IGUT, 50x the unbound Cmax at steady state, 10x the total Cmax at steady state, or 25x IUN max. And we're going to go into a little bit of depth over what those concentrations mean and why they're important. So 0.1 times IGUT. So IGUT is going to be your apparent intestinal luminal concentration. So just think about IGUT as what's the concentration in the gut. And that's going to be equal to the maximum dose that you take in 250 mils. So, that's why your doctor always says, take this with a full glass of water, about 250 mils. This calculation is going to be applicable for enzymes or transporters that are highly expressed in the intestine compared to other tissues of the body, right? So if we have higher expression in the intestine and lower expression in the kidney, we're probably going to be interested in the IGUT calculation. So you can think like CYP3A4, PGP, or BCRP all have higher intestinal expression compared to other tissues. 50 times the unbound Cmax at steady state. As we said, Cmax is the maximum concentration of plasma. We want to know the unbound concentration because, again, that's going to give us the worst case scenario. So if it's not known, we're going to take the most conservative approach possible, and we're going to assume 100% unbound. This is applicable for systemic concentrations or ubiquitously expressed enzymes or renal uptake transporters. So, for example, that's going to be like CYP1A2, OAT1, or OCT2. In contrast to 50x unbound Cmax at steady state, we also may be concerned with 10x the total Cmax. So total is going to include both unbound and bound, and that's basically just the equivalent of assuming that it's 100% unbound. And again, this is going to be applicable for systemic concentrations, non-oral delivery on efflux transporters, so like PGP or BCRP. And then the last really key calculation that we make is the 25 times IUN max, and that is the estimated unbound maximum plasma inhibitor concentration at the inlet to the liver. If the fraction unbound is unknown, again, a conservative approach is taken, so we assume 100% unbound. And this is really important for hepatic uptake. And for example, that's going to be things like OATP1B1 or OATP1B3. So once we take the information that's provided in that table that we just talked about, and we go ahead and we calculate out these four values, we can calculate the top treatment concentration that's established, and then a log scale is used to define the remaining treatment concentration. So we're always focused on the highest treatment concentration, 100 micromolar, and then we'll back down from there to our lowest concentration. A lot of times we talk to clients about this and they say, okay, great, so you need enough compound to make solutions equal to the top treatment concentration, for example, 100 micromolar. And that causes a disconnect between the client and our team because they don't understand if you're only going to treat at 100 micromolar, why are you requesting 500 mgs of compound? Well, because that's really not what we're calculating. Some organic solvents can inhibit or activate enzymes at really high concentrations. So that's why the FDA guidance states that sponsors need to keep the organic solvents at low concentrations, less than 1%, or preferably below 0.5%. So Sekisui XenoTech takes that to the next step, and we try to limit all organic solvent percentages to as low as 0.1% or up to 1%. And that's test article solubility in the test system permitting. So we want to keep that as low as possible. So what does that mean? It means that the stock solution that Sekisui XenoTech makes and then dilutes down from needs to be significantly higher than the top treatment concentration. So again, for example, if you have 100 micromolar top treatment concentration, but we only want our organic solvent to be at 0.1%, then we actually need to make a stock concentration of 100 millimolar. So that's where that test article requirement comes in. We're not making 100 micromolar, we're making 100 millimolar solution. That's what we're calculating the amount of test article based on. And if solution stability is unknown, then we need to prep fresh concentrations all the time. We can't just have a stock solution prep sitting in the -20 or the 4 degree, excuse me. So that's going to generate even more compound usage if we're having to continually make that stock solution fresh daily. So in summary, to determine the amount of test article that we need, we're going to ask for test article property information as early as possible. Based on that information that's provided, we're going to calculate top treatment concentrations that are going to meet the regulatory guidance recommendations or requirements. And then from there, we're going to use the solvent percentage that we allow in our incubations to determine the stock solution that we need to generate. And all of that information leads to the total amount of compound that's requested to be calculated. So it's not overly complicated, but those are things that a lot of the time sponsors just aren't really thinking through, and those lead to higher compound requirements than people think about a lot of the time. And so thanks for watching. Please contact your regional account manager if you're interested in placing any studies investigating your drug's metabolism or DDI potential. And also, please keep an eye out for any upcoming webinars that will be posted on the Sekisui XenoTech website if you found this helpful. Thanks again.